Hi there, I hope you're fine and enjoy the videos of the playlist so far. I haven't posted a new video for a while since I was preparing the animation of this video based on this new astonishing Python animation package called Manim. I'm pretty excited with Manim and the animation quality it provides, and I hope you share this excitement with me. Let's see. And of course, any comment or advice for further improvement on what you see here is more than welcome. So let's move on to the meat of this video. Before moving on to factors and data frames in the next videos, I intend here to present the R code solution to the first exercise of the video number 14. It was called Subsetting Character Vectors, Practice and More. In this first exercise, you were asked to subset the L1s of the students in the vector L1_sample. And to remind you, L1_sample is a vector that includes the first 50 members of the GLC_part1 vector, who at the same time have scored 13 or more out of 15 in the language proficiency assessment test. And the test scores are stored in the test_scores vectors, as you'll see in a minute, and also have had a response time less than 4 seconds based on the entries of the vector times_sample. Recall that times_sample is a vector with synthetic data, meaning that the entries of times_sample do not come from real recorded data, but they were created for the purpose of these videos with the rnorm function. So, times_sample contains a simple random sample of 50 numbers that represent hypothetical response times of a time-measured experiment of the same people in the test_scores and the L1_sample vector. Now, since each time you create a simple random sample with the rnorm function, naturally you get a different vector with 50 different random numbers. If you would like to replicate the exact same response times with this and the earlier video, feel free to visit the link in the video description below, copy its content, paste it on your RStudio console, and store the result to times_sample vector, a variable name. Following the same link, you can also copy the two other relevant vectors, L1_sample and test_sample, and test_scores, created in video number 14 and used here, and follow directly what I do in this video. Recall also that times_sample follows that the data stored in the times_sample vector follow a normal distribution with a mean of 5 and a standard deviation of 1.5 seconds. Now, I assume that the three vectors are aligned in terms of their members. Namely, the first member of test_scores records a score of a student who has had a response time that is the first member of times_sample. And the first language of that person is also stored in the first position of L_sample. And so on. Going back to the exercise, the last step for completing the exercise was to obtain the L1s of the speakers with that performance. Apparently, this last part rings a bell for using the subsetting operator on the L1_sample vector, but I suggest we take things one step at a time. There are two things that need to simultaneously be satisfied: students with scores more than 12 and response times less than 4 seconds. Translating these two conditions in R code means you simply add the pieces in place, as here. What is important to understand here is how R proceeds in executing each of the two statements. For the left statement, R takes each member of the vector test_scores and compares it with the score 12. And this is what the left part does, and the result will be a vector of logical values, as you will see. Then the same will happen for time_samples members. Each member will be compared with the number 4. that stands for 4 seconds, and the result will again be a logical vector. For finding those students with both scores more than 12 and response times less than 4 seconds, R proceeds in the same manner as earlier. Namely, it simply compares the resulting logical vectors of the two separate comparisons and outputs a new logical vector with true values in positions that both logical vectors have true values in them, and false otherwise. The ampersand or logical AND operator serves exactly that purpose. Namely, it compares the results of the first comparison with the results of the second comparison and assigns a true value only when the pairwise results are both true. Let's see the contents of the final logical vector directly in RStudio console. As expected, here you can see the resulting logical vector, but what was actually asked was to retrieve the first languages of the people with this performance. And that means you need to think in terms of what you have to do to subset the relevant first languages of the L1 sample vector. Actually, you're almost there, since you already prepared the logical vector that will function as the picking mechanism within L sample. Recall that the true values of the resulting logical vector will be translated internally as ones by R and the false values as zeros. Then the subsetting operator, represented by the square brackets as we already know, will retrieve the languages on the exact same positions that the logical vector had ones in it. So let's actually do this last step now. You enter the complex statement within the square brackets, and there you have it. The first languages of the people with score results more than 12 and response time less than 4. Take a moment to think about what one can do with such powerful subsetting mechanism. With a single line of code, you can perform now this kind of complex subsettings that serve you choose subgroups of your subjects or of your texts if you're working on corpora that meet very complex and specific criteria, so that you can focus on that group and test your hypothesis or build your models for your research. That's it for now. I hope you liked the animation and help you clear out the concept of subsetting. And of course, if you like the content of these videos, don't forget to subscribe to the channel to get notification when new videos are released. See you in the next video.